Okay, so for today, we will discuss about the thin-walled vessel. Okay, pag sinabi nating thin-walled vessel, ito yung mga container. Okay, pwedeng tubig or pwedeng gas na nilalagyan natin. Kaya tinawag siyang thin-walled, it's because we consider only the very thin. Okay, so ano yung mga cases na pwede sa kanya? So, pwedeng we will consider the cylindrical tank. Okay, and a spherical tank. Okay, so you will be having cylindrical, and we have here spherical. Okay, so because of the gas inside, no, or yung laman niya, meron tayong pressure sa loob. So we do have that pressure. Okay, now, for example, this hahatiin ko, may dalawang types, so we will consider first the cylindrical. Okay, for the cylindrical. Okay, so for example, I have here, i-cut ko muna ng paganto. Okay, horizontal. Okay, tapos ihihiga ko, no. So if I'm going to do that, so meron ako ditong, let's say, that. Okay, then of course, aanohan ko lang yung thickness. Oops, ano yung napindot? Okay, ano yung aking okay. Okay, so example, I have here this pipe. Okay, now meron yung pressure sa loob. Okay, so for example, pag ganito yung aking pressure. Okay, so yung pressure na yon, okay, all throughout yun, ano, all throughout the air, the inside area. Okay, all throughout. May pressure yan. Maraming pressure. Okay, pero yung pressure na yon, para maging resultant, okay, to get for the resultant of that pressure, ang mangyayari doon, this would become the P, and then it applies on the inside area. Okay, so dito, no? And for example, from here, meron ka dong radius. Okay, so you will be having radius. The area of the radius is actually the pi r squared. Okay? Now, what resisted those tinatawag nating circumferential stress? Okay, ang tawag natin dito is circumferential. Yung nandito sa thickness, siya naman yung lalaban. Okay, siya yung mag-stabilize naman doon. Okay, so pag ano naman siya. And it is located on the perimeter of the vessel. Okay? So, meron din yung stress. Okay? Siyempre, to get for the stress, yung resultant niya, okay? So, para makuha natin yung resultant nito, you will be having here the stress. Kaya lang, meron siyang thickness. Okay, sabi ko nga, dun siya naglalay. So, yung buong circumference mo, okay, so that's equal, sobra kasing nipis niya. So, we could say that this is just 2 pi r, or the circumference, no, ng inner circle, and then we just multiplied it by the t. Okay? So, we will be having here sigma, which is the stress, and then multiplied by 2 pi r t. Now, to have for the equilibrium, we could have its summation. So, summation natin ng forces equal to 0. We could say that P multiplied by pi r squared is also equals to sigma multiplied by 2 pi r, and then multiplied it by T, or the thickness. So that we could say that the stress would become equal to, ito kukunin natin, ilipat natin sa baba, so P pi r squared all over 2 pi r t. Cancel si pi, cancel si r, and then we could say that the circumferential stress we will be having here as PR all over 2t. Okay? So, this is called the circumferential stress. Okay? So, circumferential or tinatawag nating hoop stress. Okay? So, we will be having here this one. Okay? Next. Aside from that, okay, pwede ko naman siyang hatiin on this part. Okay, dun ko naman siya hatiin. Okay. So, kapag hinati ko siya doon, tapos ihiga ko, kuha lang ako ng maliit, ano. So, let's say, eto naman siya. Whoop. Kuha lang ako. Oh. Ay. Okay. Alright. So, dahil meron kang pressure, okay, so meron ka dito, ito, punong-puno yan ng pressure. Ulit, ano? Punong-puno ng pressure yan. And then, ito, kumuha lang kasi tayo ng infinitesimal, I will have it as dx, for example. Okay? So, dahil may pressure ka sa loob, and then again, and this one is our diameter. So, this now would become 2r. Ito yung area ngayon na kino-consider nung pinaka pressure natin sa loob. Okay? So, we could say that the resultant para doon is that would become equals to the pressure multiplied by the rectangular area. Ito po yung rectangular area na yun. Okay? So, that's equals to 2r multiplied by the dx. Okay? So, ano naman yung magre-resist sa kanya? So, meron ka dito. Okay? May stress ka dito. May stress ka rin doon. And then, those are two parts. So, para makuha naman yung resultant doon, so, again, meron kang stress doon. Ang tawag natin doon is tangential stress. No? I will have to do that. Okay? And then, yung thickness niya, eto kasi yung thickness. Oops. Okay? And then, multiplied it by the width, which is the dx. Okay. So, ngayon, if I'm going to do the summation forces, again, equal to 0. So, meron akong pataas. Kaya lang dalawa siya, no? Sa isang side dito, at saka meron ka rin doon. So, we can have it at 2 sigma tangential multiplied it by t dx is also equals to the resultant of the pressure, which is P, multiplied by 2r dx. Okay? So, dito pa lang, we could take for the tangential. So, we can have it as P multiplied it by 2r dx all over 2t dx. Cancel out si dx, cancel out si 2. We could have it the tangential stress. We can even hit 2 PR all over T. Okay? So, ayun lang. Yung isa lang is na-divide by 2. Yung isa, kung ko-compare natin, ang tawag natin dito is tangential stress. Okay? So, those are the two stresses na makikita natin. Again, this one is applicable, okay, para daw yung inner surface at saka yung etong inner surface mo at saka outer surface mo, same yung stress niya. Okay, dapat yung kanyang radius ratio to its thickness should be greater than or equal to 10. Okay? Otherwise, kapag makapal na yung vessel mo, iba na yung pressure or iba na yung stress na nararanasan ng inner surface at saka iba na yung nararanasan ng outer surface. Okay po? So, I'll give you another 5 minutes to copy. Okay, so let me correct. Okay, I am wrong with this. This is what you call the uh, circumferential stress, not baliktad. Okay, it's called circumferential stress. Okay, ito ang tawag natin dito is longitudinal. Longitudinal, baliktad eh. Longitudinal stress. Baliktad. Or hoop stress. Okay? Yan. Sige po. Kopya muna. I change it to sigma L ano, and then sigma C. So, para mas tama. Circumferential and longitudinal stress. Okay. So, a cylindrical steel pressure has hemispherical end caps. The inner radius of the vessel is 24 inches and the wall thickness is constant at 0.25 inch. When the vessel is pressurized to 125 psi, determine the stresses and the change in radius of the first cylinder. Second is the end caps. Use E equals to 29 times 10 to the 6 psi and then the Poisson's ratio of 0.28. Okay. So, unahin muna natin yung ating letter A. Okay. So, for the cylinder. Okay. Yung madali muna. Actually, hindi naman parehas lang pala. So, may dalawa tayo kapag cylinder. So, we have here the circumferential and we have the longitudinal stress. Okay. So, nahin natin circumferential stress. Again, mayroon tayong formulang P, R, all over T. Okay. So, we can have it 125 for the pressure, PSI. And then we have the inner radius, which is 24 inches. And then all over, we will be having here the thickness, which is 0.25 inches. Okay, or we will be having here 125 times 24 over 0.25, or we have here 12,000 PSI. Okay, so ito na yung sagot. Okay, madali lang ano. So again, you can have now the longitudinal stress. So we can have as PR all over 2T. Okay, or it's just equals to circumferential divided by 2. So we can have it divided by 2. We can have it 6,000 PSI. Okay? Now, para makakompute tayo, kasi para makompute natin yung change in radius niya, okay, we need to have what we call the strain, okay? Kaya lang since this would be biaxial, pag sinabing biaxial, no, dalawang directions yung stresses natin. Sabi nga natin, isang is circumferential at isang longitudinal. Okay, so that para makuha natin yung pinaka-strain niya, gumagamit tayo ng biaxial Hooke's law. Okay, so paano yung biaxial Hooke's law? So, using the biaxial Hooke's law. Okay, so for the biaxial Hooke's law, so to have for the strain, okay, if we are considering for the strain of the circumferential, kasi mas malakas yung stress natin dun sa circumferential, ano? So, we will be having here circumferential. So, actually, that is just equal to the mataas na stress in one direction, which is our circumferential. And then, ima-minus natin yung stresses dun sa longitudinal. Kaya lang, meron siyang Poisson's ratio, no? All over E. Okay. So we do this. So, this is now the biaxial Hooke's law. Okay. So, to get for that, we will be having circumferential. We have 12,000 minus the Poisson's ratio of 0.25 multiplied by 6,000 all over. We will be having here the E, which is ilan yung inga natin? 29 times 10 to the 6. So we have the circumferential, okay, strain. So 12,000 minus 0.25 times 6,000 all over 29 times 10 to the 6. So that is 3.62 minus, it's 0.28. Sorry, it's 0.28. So that's 3.50, okay, ilan na lang, times 10 to the 6, 355.9, 355.9 times 10, okay, to the negative 6. So this is a unit less, okay, so you can have that. Next, to solve, sabi nga natin, so sa strain, actually yung strain natin, okay, sabi natin that would become equal to what you call this one, deformation all over the L, if you still remember. But since we are speaking for the radius, this would become change in radius all over the original radius. And we are trying to find the change in radius, so we can have it the circumferential stress multiplied it by the radius. So that we can have it as 355.9 times 10 to the negative 6, and then multiply ako by original radius, which is 24 inches. So that you can have it the change in radius. Okay, I stored it in letter A on my calculator so that I will be having an exact strain. Okay, so I will be having here as 8.54. Okay, I have here 8.54 times 10 to the negative 3 inches. Okay, so this is now the change in radius for the cylinder. Okay, how about for the end cups? Okay, yung end cups natin, again, that is spherical. Okay, if you could remember yung ating tawag dito, yung derivation natin, ang spherical para siyang palaging longitudinal stress lang. Okay? So isa lang yung formula pag spherical. Okay, we will be having just here PR all over 2T. Okay? So ibig sabihin, kasi kahit saan mo siya ikat ikat mo dito or ikat mo doon, parehas lang yung cylinder. Okay? Parehas lang cylinder. Parehas lang yung spherical. Okay? Or circular, yung pinaka-long, ano natin, yung longitudinal stress natin. Okay? So, whether ito or pag ganon, in two directions, so in horizontal and vertical direction, in two axis, so parehas lang sila. Okay? So, it means yung circumferential na makukuha niya, tsaka yung longitudinal, parehas lang yon. Okay? So, we will be having here the PR. Okay? So, same thing. We can have it as 125 multiplied by 24 all over 2t, which is again 0.25. Okay? So, you can have it 6,000. No? Same lang. Okay? So, this is the stress for the end. Okay? Ang naiba lang dito is this one. Okay? So, yung ating strain. Okay? So, since parehas sila, so, strain minus strain. Stress minus Poisson's ratio times stress all over E. Okay? So, I use the biaxial Hooke's law. Okay? So, ganun din. Sabi ko nga, parehas lang silang dalawa. Okay? So that we can have it as 6,000 minus 0.28 of 6,000 all over 29 times 10 to the 6. So that I have here the strain 6,000 minus 0.28 of 6,000 all over 29 times 10 to the 6. Or I will be having here as 1 point, sige gawin kong times 10 to the 6. 148.97 times 10 to the negative 6. Again, that is unitless. Okay? So, to solve for the change in R, again, we can have it the strain multiplied it by the original. So, that is 148.97 times 10 to the negative 6 multiplied it by the original, which is 24. So, that the change for the end cups would become equal to 3.58 times 10 to the negative 3 inches. Okay? So, these are now the answers. Again, ito answers din to. No? These are the stresses on the end cups. Okay? So, that's it for this problem. So, you have 5 minutes again to copy. Okay, so here's the question. A spherical shell with 70-inch outside diameter and 67 inches inside diameter contains helium at a pressure of 1,200 psi. Compute the stress in the shell. Okay, since this is just spherical, isa lang yung formula natin for the stress in both directions. So, it is just equals to PR all over 2T. Okay? So, again, yung R natin, that would be the inner radius. So, if this is your outer diameter, okay, and then this is your inside diameter, for example. Okay? So, yung ating outside diameter, and that is equal to 70 inches. And then we will be having here your inside diameter, which is equals to 67 inches. And then yung nandito, we have here the T, and then we have here the thickness. Okay? So it means 67 inches plus 2T is equals to 70 inches. Okay? So we can now solve for the T, or that is 70 minus 67 divided by 2. Okay? So we can have it as 1.5 inches. Okay? And then we can now have this stress. So we can have it the P, which is 1,200. The radius, and we are speaking here for the radius, we can have it as inner diameter divided by 2. So ang inner diameter ko is 67 all over 2. Okay? All over 2T. So we can have it the thickness, which is the 1.5. Okay? So we can have here the stress. 1,200 times 67 all over 2. 1.5. Okay? So we can have this 13,400 PSI. Okay? So this is now the answer for the first problem. This is the problem in Kyosala's book. No? Okay. So, this time, I'll give you only 3 minutes to copy. So, maliit lang naman yung konti lang na may solution. Okay, so let's have this problem. A spherical fresh pressure vessel has a 1.5 feet inner radius and 3 over 16 inches wall thickness. If the working tensile stress of material is 6,000 psi, determine the maximum allowable internal pressure. Okay, again, the working stress for this one, since this is a spherical, is just PR all over 2. Okay, so you can have it the working PR all over 2T. Okay, but this time we are just looking for the P. Okay, so rearranging for the P, we can have it as 2 sigma T all over the R. Okay, yung ganun lang. So we can have it this yung ating thickness, so we can have it as the P is equals to 2 and our working stress is 6,000 psi, and then the thickness is 3 all over 16. Okay, all over we have the radius. So however yung radius natin is naka-feet. Okay, so we can have it as 1.5 feet. Para maging inches siya, i-multiply natin by 12. Okay, so that this become inches. So we can now have the required pressure, which is 2 times 6,000 times 3 all over 16 all over 1.5 times 12. Okay, so you can have it as 125 psi. So hanggang dito lang yung kailangan niyang yung kaya niyang pressure. Otherwise, masisira na yung pinaka-tank natin. Okay? So in our cases, kapag kayo ay nagde-design na, it's either you have like this, no? So pwedeng tanungin, ano ba yung kaya lang nung dalin nung pinaka-material natin bago siya bumigay. So it is our duty para alamin yung mga bagay na ganun, yung loads. Okay? So, for this case, hanggang 125 PSI lang yung kaya ng pressure sa loob. Otherwise, it will break. Okay po? So, I'll give you another 3 minutes to copy. Okay. So to determine the strength of the riveted joint in a cylindrical vessel, tensile tests were performed on a 6-inch wide specimen as shown. The tensile force P at failure was found to be 32 kips for longitudinal joint specimen and 16 kips for the circumferential joint specimen. Determine the largest allowable inner diameter of the cylinder that can support a pressure of 150 psi with a factor of safety of 2.0. Okay. So, hindi nyo yan magigets kung ganyan lang yung nakikita nyong figure kasi mukha siyang lap joint na pinag-aralan natin no nakaraan. No? Okay, so let me draw first, for example, no, since this is a cylindrical. Okay. Minsan kasi wala tayong mabibili or mahirap in manufacture yung malalaking tangke ng tubig or malalaking tangke ng gas sa mga petrochemical plants. Okay? So ang ginagawa doon is by plates. Okay? So from a certain plate, for example, ayan lang yung plate mo. Okay? Ayan lang yung nabibili. Okay, may certain sukat lang yan, may certain laki lang yan dahil sa manufacturing constraint, no? So, ika-curve yan, okay? So, pag kinerve yan, for, let's say, ito na yung cylinder, pwede siya munang ma-curve ng hanggang ganito lang. Okay? Kasi hanggang dyan lang yung pinakakaya mo eh. Okay? So, what happened is, dudugtungan yun. Okay? Dudugtungan. Okay? Ayan, parang meron siyang dugtong. Okay? So, meron siyang lap. Oops. Mali. Ayan. Parang meron siyang lap doon. Okay? May dugtong. May overlapping na nangyayari. Okay? And then, dito naglalagay ng mga bolts. Okay? So, ayan, nilalagay niya ng bolts. Okay? So, syempre, this one, yung, kapag natanggal siya, di ba? Okay, for example, natanggal siya. Ayun yung stress doon. Okay, so meron tayong type ng stress na gano'n. So, ito yon. So, kumbaga, kumuha lang siya ng specimen for about, let's say, ayan, kumuha lang siya ng 6. Okay, so ito yon. Ito yung itsura nun. Okay, kumbaga, parang ganyan yung naging itsura. Kumuha siya ng 6 para dyan. Okay, ngayon, pwede rin naman na hindi rin kasya dito. So, ang gagawin dito, parang, oops, ay, hindi kaya. Masyadong mahaba yung aking tank. Okay? So, dito naman, along its circumference, maglalagay naman siya ng mga bolts doon. Okay? Okay ng mga welds doon. So, dalawang specimens daw yung ginawa. So, isa sa longitudinal at isa is para sa tangential. Okay? So, unahin natin for the circumferential. Okay? So, we have here the circumferential. Ang working niya daw is the stress. Okay? Again, P over A kasi tensile to eh. Okay? Kaya lang, we can have it the factor of safety. Okay? So, normally, yung factor of safety, if it is more than 1.0, okay? So, ang ginagawa natin doon is i-divide natin sa working stress. Okay? Or doon sa kanyang capacity. When I say working stress or allowable stress, when I say allowable stress, okay, iyon yung capacity ng material mo, okay, to resist a certain load. Okay? So, parang factor of safety, let's say, ang kaya ko talagang buhatin is 100 kilograms lang yung kamay ko, no? Pero dahil sa factor of safety, hindi ko ipapabuhat lahat. So, gagawin ko, i-divide ko by 2. Factor of safety ko is 2. So, instead na 100 kilograms, ang maximum lang na ipabubuhat ko is 50 kilograms lang. So, meron akong factor of safety na 2. So that, kapag nangyari, let's say, accidentally, nakapagbuhat ako ng 65 kilograms, although it exceeds my maximum allowable dahil sa factor of safety, hindi pa rin ako masisira. Okay? So, kailangan sa engineering, sa atin, may tinatawag tayong factor of safety. May margin of error, no? Minsan sa construction, minsan sa manufacturing. So, hindi pwedeng pag binigay natin, hindi pwedeng kapag binigay natin yung maximum load na kaya niyang dalhin, hanggang doon na lang. More than that, masisira na, no? So, we have the factor of safety. So, normally, we divide it by 2. So, instead na P all over A lang siya, i-divide ko siya by factor of safety. Okay? Minsan N yung nilalagay, minsan Fs. Okay? So, yung P na nakukuha ko, una sa circumferential, sabi niya is 16,000. Ayan, nasa na yon. Ang sabi niya, we can have it as 16. Ayun, 16 kips ano? Or 16,000 pounds. So, we can have it as 16,000. And then again, the factor of safety is 2. And then the area. Okay, ito daw ay 6. Okay, 6 inch yan. And then we can have it the T. So, ito yung area mo. So, we can have it as 60. Okay? And this would now become equals to 4,000 all over 3T. Okay? Again, this is in PSI. How about for longitudinal? So, again, dalawa daw yung specimen na ginawa, ano? So, isang isang circumferential at isang longitudinal. So, ganun din. So, we can have it as P all over NA. But this time, this is 32,000. Okay? All over. We can have it the factor of safety multiplied by the area, which is 60. Or that is equals to 8,000 all over 3T PSI. Again, this is all allowable stresses. Okay? Allowable stresses, or that is the capacity. Okay? Now, sa cylindrical shell, okay, ang alam natin, sabi natin, di ba, kung papansinin natin, yung ating circumferential stress is twice palagi ng longitudinal stress. Okay? With this mean that the circumferential, okay, for a design governs. Okay, almost. Okay, lagi na. So, ang gagamitin natin, we will look for the circumferential stress. Okay, so, dapat mas malakas kasi kapag, ano yung tawag natin dito? Kapag nagkaroon niya ng pressure, okay, tapos same lang yung strength ng dalawa, normally dito masisira yun, ano. So, kailangan is mas malakas yung connection natin dito kumpara dun sa ating longitudinal. Okay? So, we can have that principle. Okay? So, ang gagamitin nating formula, of course, is the circumferential stress dahil mas governing siya. So, ano yung formula ng circumferential natin? So, we can have it as PR all over T. Okay? Yung walang 2. Okay? So, we can have our R. Okay? So, ang R natin, that would become equals to T multiplied by the sigma C all over the P. Okay? So, yung T natin, multiplied it by the sigma C. Ano yung sigma C natin? Ito, no? So, 4,000 all over 3T. All over the pressure, which is 150. So, that would be the radius. Cancel si T. So, yung R natin would become equal to ilan yan? 4,000 divided by 3 times 150. So, that would become 8.89 inches. Okay? Ang tanong is, ano may tanong? Allowable inner diameter. So, that yung diameter natin, of course, 2R lang. So, ang diameter natin, times lang natin by 2. So, we can have it as 17.77 inches. Okay? So, this is now the required inner diameter for the working tensile stresses. Okay? So, sige po. I'll give you 5 minutes to internalize and copy. Okay. So now we will now proceed. We will start to proceed, and maybe this would be the last topics that I will discuss on the deformable bodies. So hindi ko siya pwedeng neglect because in the past board exams, marami yung combined stresses. Okay. So even in my board exam, we had this kind of combined axial and lateral loads. Okay. What does it tells us? Okay. So, diniscuss natin before the normal P over A, the normal stresses, and then for the beams, may diniscuss tayong dalawang klase, ano? We have the flexural stress, and then we have also this shearing stress. Okay? So, again, to mind you, yung ating flexural stress, okay, sabi nga natin, di ba? So, meron tayong ganyan. Okay? So, kapag we will be having here, meron tayong C-top, and then meron tayong C-bottom. Okay, C-top, and then C-bottom. Okay. And then from there, nababago-bago yung ating stresses. Okay, depende doon sa location niya. Okay. So, pero, okay, like, gawin ko, ano siya, no? In three-dimensional. For example, we have this kind of beam. Okay? And then, ito yung kanyang C. Okay? Because of the moment, a certain portion, okay? Parang yung portion natin na to, okay? A certain portion, okay? Nako-compress siya. Okay? It is being compressed. Okay? Para siyang merong normal force din doon. Okay? And then, yung baba, okay, yung the other portion, nagiging tension naman siya. Okay, tension and then compression. Okay, if you still remember. In short, itong tension and compressive force na yan, para rin siyang normal stress. Ano? Kumbaga yung flexural stress natin, although we called it flexural stress, pero para siyang normal stress din. Okay? Pag sinabi natin normal stress, the force is perpendicular. Okay? Now, we experience this kind of stresses kapag merong bending moment yung ating member. For example, ito, meron tong bending moment, ano, makakakita ka dyan ng, you can have that, the bending moment. Okay? So, ayan, di ba? I-drawing natin, for example, hypothetical, we have the reaction here. Ayan, we have, ayan, parang magiging ganyan yung ano eh. Oops. Mali. Ayan. Ganyan pala dapat. Oops. Hypothetical. Okay. Tapos ito, the bending would be look like this one. Okay. So, parang ganyan. No? As long as you have here the bending moment, meron tayong flexural stress at certain point. Okay. For example, at this point. Okay. Example at this point. Oh. Ay, hindi nagtama yung ano, pero dapat dun yun. So, ito wala kang ganyan lang. Example for this point. Okay. Because meron ako dong moment, meron akong P all over A. Okay? And then again, this tells us kapag ganito kung nasaan yung compression. Kung nasaan again, para madali nating malaman kung nasaan yung moment diagram dun sa beam, nandoon yung ating compressive force. Okay po? So, in short, ito, nasa taas yung moment natin, nasa taas yung compression. Okay? So, some part of it is compression and some part of it is tension. Again, this would become, tawagin kong negative, no? MC all over I. And this one is also MC all over I. Okay, ayan. This is due to these forces. Okay, due to these forces, okay, due to the bending, meron akong compression and tensile forces. Okay. However, because of this force, additional force, no, lateral, okay, ibig sabihin, pag sinabi kong lateral, horizontal load, okay, or aligned doon sa line ng member. Ito yung axis ng member eh, aligned dyan, okay. So, ayan, example, ayan yung beam mo, okay, ayan yung beam mo. Meron ka pa daw force doon. Siyempre ito, it also experiences compression, ano? But this time, yung kanyang hull, okay? Whether kalahati yan, lahat yon nako-compress. Okay po? So, lahat daw yon is nako-compress because of that. Okay? So, in short, I would also tell, okay, I'm going to have it as negative P all over A kapag compression. Okay? So, I will have it as negative P all over A. Ito rin, negative P all over A. Okay? So, again, the negative signs tells us that a certain portion of the beam is in compression, and then a positive sign is a certain point on the cross section where it is in tension. Ngayon, i-combine natin silang dalawa. So, in short, I will make it plus. Okay? So, yung taas pala ng beam ko, okay, yung pinakataas, yung most, at certain C, no? At certain C. So, yung pinaka-total stress niya would become equals to negative P all over A, and then plus negative. Kaya lang plus and then minus. So, I will have it as minus C or MC all over I. Again, this is the stress at the top. Okay? So, it also shows us that this is in compression. However, yung pinakababa, I will be having here as negative P all over A because this is in tension, magne-negate ng kaunti. MC all over I. So, this now would become your bottom. Okay? Now, through the diagram, I will be having here this one. Okay? So, for example, okay, since nasa gitna siya, I will be having here, ayan, and then, diagram na, ayan, parang ganyan yung ating pinaka-beam. Okay, ito yung gitna, ito yung longitudinal, okay? Tapos, ito, since we called it as compression, papunta dun sa cross-section. Tapos, yung, sorry, ito pala ay tension, ano, kasi pahila pala siya, so pahila sa cross-section. Oops. So, this is in tension. Yan, baguhin ko na nga. Ayan. Okay? So, plus, ito pala ay tension, and ito pala ay tension. Kasi pahila siya, okay? So, we will be having here tension. Okay? Now, this is in tension, so pahila daw to. Okay? Again, this is negative MC all over I. Top to, no? Top. And then this is plus MC bottom all over the I. Plus, para naman dun sa ating F1, okay, due to F1, kapag poopy all over A lang, okay, constant lang siya. Yan, constant lang yung nagiging ganyan. Okay? Puro pahili. Okay? And we call that yung stress as P all over A. Ayun siya. P all over A. Kaya ang resulting diagram ng beam natin, for example, we have here the beam. Okay? Nakita nyo to, ito pahila, nag-add siya. So, ito is medyo lalaki. Oh, ayan, parang ganun ano. Tapos ito kasi nabawasan siya, so medyo liliit yon. Okay? From the center line, magshi-shift yon somehow. Okay, kasi maliit lang to eh. Okay, kailangan kasi proportional yan eh. Oh, ayan, pwedeng dyan, no? Hindi natin alam, so depende yan sa magiging value. Okay? So, ito yung magiging tensile, ito yung buong, ito yung magiging compression, ito yung magiging buong tension. Okay? So, it means na kapag lumalaki yung moment mo, okay, nagbabago rin, nagsi-shifting din yung lateral, no? So, sa ibang book, actually kay Pytel, ganito yung ginagawa. Pero pwede rin na ganito, no? So, ayan. Kasi lagi silang proportional. Let's say, yan, mahabang ganyan. Eh. Para mag-shift ng ganun. Ayan, makikita nyo kagad yung shifting doon. Okay? So, this one would be in tension. Okay, and this one would be in compression, and this one would be in tension. Okay? So, kaya ginagawang ganito, mas maganda kasi ginagawang ganito. Okay? Para nakikita natin kung tension ba ay papalayo or yung compression ba ay papalapit dun sa pinaka-cross section. Okay, so mas madaling i-distinguish. Pero both are the same, no? So, pwedeng ganito, pwede rin ganito. Walang problema. Okay, as long as we understand the principle of the tension and then compression. Okay, with this, I will give you first 5 minutes to copy and then we'll proceed with the problem. Okay. To reduce interference, a link in a machine is designed so that its cross-sectional area in the center section is reduced by 1/2. The thickness of the link is 50 millimeters. Given that P equals to 40 kilonewton, one determine the maximum and minimum values of the normal stress acting on the section MN. To sketch the stress distribution on section MN. Alright. So, ganito, if you will just, imagine, okay? Kapag ganyan yung bagay, okay, I think maano na kayo ngayon sa medyo imagination. Kapag hinila nyo yan, paano yung magiging deformation yan? Magdi-deflect yan ng parang paganto eh. Okay. Oops. Yan. Tama ba? If you could imagine, no? Dahil hinihila mo, magiging ganyan yung deflection yan. Okay? If a certain body has a deflections or yung paglundo, no? Pag-deflect, it means it experience a moment. Okay? At a certain point. Okay? That's because of tinatawag natin na tawag natin dito is non-prismatic. Okay? It means all throughout the sections, all throughout the length niya, hindi magkakamukha yung cross-section. Okay? Ang tawag natin doon is non-prismatic. Okay? Kapag sinabi natin prismatic, ibig sabihin, all throughout the length, magkakamukha yung cross-section. So, normally, due to the axial loads, wala yung nagiging deflections. But for a non-prismatic member, tapos nagkaroon ka ng axial loads, parang ganito yung magiging itsura niya. Okay? So, alam natin na meron niyang P all over A because of the force P na nandito. Okay? Which is in tension. Pero sabi meron daw 50 mm, so lagyan ko ng lagyan ko ng konting, lagyan ko ng, ayan, 50 mm yun eh. Okay? So, ngayon, gagawin natin, dahil nandito cross-section, dun ko siya ikakat. Oops, okay. Tapos, ilipat ko sa kabilang body. Okay? So, I will be having here this kind of okay? Ayan, para magiging ganyan. And then, nandito yung cross-section, nandito yung aking force P. Okay? Siyempre, dapat, sabi nga natin, if we try to cut a certain section, dapat magkakaroon ka rin ng force in equilibrium. Okay? Nasaan ngayon yun? Since, dito kasi, at this point, kung saan tumatama, okay, gawin ko na ulit 3D. Oh, ayan, parang ganyan. Ayan. Kung saan tumatama itong pinaka-force ko na yan, nandito yung kanyang center line. Okay, so I will be having here the center line. Okay, nandyan yung kanyang center line. Pero dito, to resist this force P, yung na-cut na cross-section, meron din yung P. Pero again, located din yun dun sa kanyang center line. Okay? So, dapat center to center, So, yung center line na yon, if this is, sabi natin 40, so ito, 40 na lang din to, no? So, 40, ayan, i-drawing ko ng iba. Oops. Para mas okay. Ayan. Okay? So, in short, nandito yung aking isang P, and yung isa nandito sa aking isang P. Okay? So, nasan yung kanyang, ito yung kanyang line of action, and then yung isa naman, nandito yung isang line of action niya. Okay? So, they are separated by a certain distance. Okay? Ang tawag natin doon sa separation na yun is actually eccentricity. Okay? So, yung eccentricity natin na yun, sabi niya, okay, tingnan natin So, dito. So, kung 40 to, ito daw ay 40. So, this one would become equal to 20, and then this one is also equal to 20. Okay? Now, ito ay equilibrium only on the direction of forces. Okay? So, merong P sa kanan, merong P sa kaliwa. So, they are equal to 0. Pero, if you will notice, these two forces forms a couple. Okay? Tapos, yung couple niya, papaikutin siya paano? Papaikutin ng couple na yun ng pa-clockwise. Okay? So, that, iyon yung iikot yung body natin. So ngayon, para ma-oppose yun, dun sa pinaka-cross-section natin, magkakaroon din yun ng moment. Okay? Magkakaroon yun ng moment. Ngayon, yung direction ng moment na yon, it should equalize the couple produced by the force P. Ayan, nakita natin yung P, ano? So, hinila mo dito. So, P, hinila mo doon. So, para siyang pinapaikot. Okay? At this point, para siyang pinapaikot ng pagganon. Okay? Pa-clockwise. Okay? So, kailangan i-oppose niya yon. Okay? So, i-oppose natin yon by this. Okay? Kaya, pa-counterclockwise. And we will call that as the M. Okay? So, yung P na to, yung moment na yan, actually, this force P created, is should become equal to this one. Ano yung na-create na yon? And that would be the P multiplied it by the eccentricity E. Okay? So, yun yung ating eccentricity. Okay? So that, itong body na to, nakaka-experience siya ng P, nakaka-experience siya ng moment. Okay? Which is the moment, which is equals to P multiplied it by the E. Or that is actually the moment created by the couple due to eccentricity. Okay? So, kaya pag may narinig kayong eccentricity, ibig sabihin, yung dalawang force niya, they are equal, however, they are not located at the same line of action. Okay? So, ibig sabihin, they fall on the different lines. So, yung ito, dito nag-a-act yung kanyang line of action, yung isa dito nag-a-act yung kanyang line of action. So, meron kang eccentricity. So, to solve for that moment, and that is just equal to P. Ano yung P natin? 40 kilonewton. And then, para maging kilonewton meter, okay, ito gawin kong meter, ano? So, 0.02 meters. O, ilan yung eccentricity niyan? 40 times 0.02. So, that is equal to 0.8 kilonewton meter. Okay? So now, meron ka na nito. Check natin yung cross-section, ano? Check natin cross-section nito. Okay? Dito sa MN, okay? Dito sa MN, so meron tayong dalawa, no? Unahin natin yung due to force P. Due to force P. So, yung due to force P, okay? Both on top, dapat dalawa yan eh. Top and bottom. Okay. They produce the same stress. Okay. Again, it's just P all over A lang yan eh. Kaya lang, this is in tension, so we will be having here plus P all over A. And then plus P all over A. Okay. So, ang P ko is equals to 40,000 Newton. At ang area ko is this area, no? Ito yung area na to. Okay? Again, mula daw dito hanggang doon, that is 40. And meron kang constant thickness of 50. So, you can have it as 40 multiplied it by 50. Same lang yun. Okay? So, we will be having 40,000 all over 40 times 50. Or you can have it as tensile of 20 megapascal. So, ito rin, meron din akong tensile na 20 megapascal. Okay? However, due to moment M. Okay? Meron na ako ngayong parang flexural stress, ano? So, meron ako ditong, okay, this is 50 and then this is 40. I will now have the I equals to BH cube all over 12. So, again is B H cube all over 12. So, you can have it as 50 times 40 cube all over 12. So, you can have it as 26,000 666.67 mm to the 4th. Okay, so I will store that at my A. Okay, so again, we can have it as top and we can have it as bottom. Okay, tatanungin natin, oops, sabi niya, lagi ang tanong dun sa araw, no, sa moment natin, nasaan si compression? Okay, so sabi niya, oops, tinuro niya, oops, nasa taas daw si compression. Okay, so we will be having here the top as the compression and then the bottom is our tension. Again, this is very symmetrical. So we can say that yung ating C top is 20 at ang ating C bottom is also 20. Okay? So we can have it the M. Okay? So 0.8. Again, gawin natin Newton millimeter. So times 10 to the 6. Ang C natin is 20. At ang I natin is what? 266.67. So same thing dito. Kaya lang, instead na it is compression, magiging tension siya. Yan. Hirapan ako magsulat. 266.67. Okay? So you can have this one. So 0.8 times 10 to the 6 times 20 all over 266. So you can have it as 60. Negative 60 megapascal. And then you have here positive 60 megapascal. So, pwede ko na ngayong pagsamahin. Okay? So, due to combined, we can have it as top and we can have it as bottom. Okay? So, sa top, meron akong positive 20 megapascal and then meron akong negative 60 megapascal. So, I have here negative 40 megapascal. Okay? And then on the bottom, I have here 20 megapascal and then another 60 megapascal. So you can have it as tension 80 megapascal. So this is now the stresses, the maximum and then the minimum stresses. Okay? So you can have these two. How about the diagram? Okay, so para hindi tayo mahirapan, unahin natin due to the force P. Okay? Due to the force P, again, lahat ay paganto. Okay? Okay. Oops. Ayan. Lahat yan paganyan. Okay? So again, this is positive 20. Ito yung cross-section natin. Ano? Ito yung cross-section natin na 50 by 40. Okay. So yeah, lahat yan ay 20. Positive. So positive 20. Plus, due to the MC all over I. So we could see, okay, so gitnang-gitna. So ayan, gitnang-gitna yan. Sir, paano ako nasabing gitnang-gitna? Kasi pareha sila ng value eh. Kaya lang yung isa is negative 60. So pag ganito siya, pag ganyan siya, how about this one? Papalayo naman siya. Okay? So, ngayon, yung line dito, okay, yung line dyan, 20 naging negative 40. What does it mean? So, still, it is in compression. Okay? And then, pagdating doon, kaya lang, we can have it here. Maliit na lang siya. So, that is negative 40. Yung isa malaki, no? So, you can have, ayan, parang doble eh. So, positive 80. Okay, so, instead, mas malaki to, syempre, mas malaking triangle. They should be similar triangle, ano? So, they should be similar triangle. Oops. Ayan. Somehow, ganyan. Sige. Ayan. Pag ganyan siya, no? So, again, this is in compression. And then, this is in tension. Okay? Sir, possible ba na makita to? Okay, ano yung distance na yan? Possible ba na makita yan? Yes. Again, sabi ko nga, they are perfectly symmetrical. If this is y, we call it as 40 minus y. So, we can have it as 40 is to y is equals to 80 is to 40 minus y. So, may mako-compute kang value ng y. So, that is 40 is to x. Okay, I'm trying to have it shift solve, ano? So, oops. Alpha x. Okay. So, we can have it the value of y, which is 13.33 mm. Okay. So, ayun, yung distance na yan is 13.3. Okay. So, ito yung ating stress diagram. Akin, due to M, P over A, and MC all over I. Pag-aadin mo sila. So, this one is P all over A plus MC all over I. So, again, this is due to the combined loadings. So, in final state, yung top down natin ay nakaka-experience ng compression ng 40 megapascal at yung bottom natin nakaka-experience naman ng 80 megapascal in tension. However, hindi na kalahati. Dito kasi no, sa una, no, nasa na yung una. Kalahati nakaka-experience ito. Kalahati nakaka-experience ng tension, kalahati nakaka-experience ng compression. But sa final state niya, mas marami yung nakaka-experience ng tension kumpara doon sa compression. Okay po? So that's how you do for the combined loadings. So ayan, medyo mas nakakalito ng konti. So I would give you examples on this, and I will also give you some problem sets. Okay? Before we proceed with the last topic, which is the state of stresses. Sige po, I'll give you 5 minutes again to copy. Okay. The wood beam ABCD carries two vertical loads. The beam is supported by a pin at A and a horizontal cable C. Determine the magnitude of the largest stress in the beam and its location. Neglect the weight of the beam. Okay. So una, syempre we cannot go um, without having the statics itself. Okay? So from this, gagawin natin, we will try to have the forces. So ito yung cable CE. Okay? So that I could have now the summation moment at A. Okay? I will try ito, meron ako ditong reactions definitely. So we can have it as AY. Okay, and then I will be having here as AX. Okay? Since pa left side yung CE, so I assume that the AX is on the right. So, summation ako ng forces. Actually, pwede na pala, no? Kahit ano lang, summation forces vertical. Anyway, summation ako ng moment at A equal to 0. So, I will have it as clockwise to be positive. So, I will be having here 6,000 multiplied it by 4 plus 3,000 multiplied it by length of 4, 12, 4, 8, 12. Okay? And then minus, I will be having here the CE multiplied it by 6 equal to 0. Okay? So I have here now the value of CE. So ilang pounds yun? So that is 6,000 times 4 plus 3,000 times 12 divided by 6. 6, sorry. It's 8. Sorry. Tama pala. Ito pala yung aking tinutong ko. Tama. That's 6. Divided by 6. So you can have it as 10,000 pounds. Okay? So I can now have summation forces horizontal equal to 0. So we could say, dalawa lang naman yung horizontal natin eh. So I could say that my AX is also equals to 10,000 pounds. Okay? And then for the summation forces vertical equal to 0, upward is positive. So I can now have as AY minus 6,000 minus 3,000 equal to 0. So I could have the AY equals to 9,000 pounds. Okay. Now, itong mga forces na to, okay, kailangan kasi it would be directed along this line, ano? So, dapat yan, ma-component natin lahat along this line and vertical. Okay, dapat in orthogonal axis, parang pa ganyan. Dapat i-ano natin ng pa ganyan siya. Okay? So, ngayon, iisa-isahin natin yon. Okay, so medyo matagal kasi naka-incline na, no? So, kaya mahirap kapag yung naka-incline siya. Okay? Yan. So, para hindi kayo malito, kunin nyo na lang yung angle. Okay? So, sige. I think masanay kayo sa angle. So, someone told me masanay sila sa angle. So, kukunin ko to. I will be having here the theta. Okay? So, paano kukunin ng theta natin? So, that is arctangent or tangent raised to negative 1 of its 6 all over 8. Okay? Ayun. 6 all over the 8. Okay? And then, store nyo na lang sa inyong values. Arctangent of 6 all over 8. So, that is around 36.87 degrees. Okay? Ayan. Ilagay ko sa A, no? So, ayan. I will be having here for my A sa calculator. Okay? Ngayon, i-component. This one is theta. So, ito, nasan yun? Nasan yung theta na yun? Okay, ito yung theta eh. So, ito, this would become 90. Okay? 90 minus theta yan. Okay? Kasi ito yung theta ng isa. Oops, ayan yung theta. So, ito 90 minus theta. Okay, ito ano to? Again, horizontal siya galing. So, this one would become equal to what? Again, 90 minus theta din. Okay? So, ayan. Kung nalilito kayo, ayan. Lagyan na nga natin ng lines. I-diretso natin. Oop. Ayan. Okay? So, ilagay natin dito. If this is theta, this is 90 minus theta. Okay, of course, this is, ilan to? This is our 90 degrees. Ano? Ayan, para sa triangle na yun. Kung nakikita nyo yung triangle, if this is theta, this is 90 degrees, then this is 90 minus theta. If this is 90 minus theta, this is also 90 minus theta. Baguhin ko yung color. This is also 90 minus theta. Okay? I hope you got it right. Okay? So 90 minus theta is 90 minus theta 53.13. Lalagay ko naman siya sa B. Okay? Okay, now itong AX, okay, i-component na natin, ano? Component na natin. Pero una, lagay ko muna to. Points A, B, C, and then D. So A, B, C, and then D. Okay. So i-component ko to. Okay. So that I will be having here this one. Okay. And then I will be having here this one. Perpendicular. Okay. So for this case, this is AX. Okay. And then para ma-component ko siya into vertical and horizontal, ayan, dapat makita nyo yun. So pag ganyan siya, if this is 90 minus theta, yung para dito, that is the sine. Okay, so ibig sabihin, this is AX sine of 90. Oh, tawagin ko tong beta, no? O B. Ayan. B. Okay? And then ito, tatawagin ko tong AX cosine of B. Okay? Kaya lang pagdating sa AY, oh, may AY pa pala ako eh. If this is, okay, nasa na yan? Kasi it should be perpendicular. Oops. Ayan, kung nakikita nyo. If this is 90 minus theta, so this is also your theta. Okay? So, this is now 90 minus theta. And this is your theta. Okay. Nagigets nyo ba? Kasi ito is 90 din kasi. Ayan, they are 90 degrees, diba? So, if this is, ito rin 90 degrees. So, if this is 90 minus theta, this is theta. And if this is 90 degrees, this is theta. And then this is 90 minus theta. And then this is theta. Okay? So, ito naman gamitin ko. Yung theta dito. So, para pa ganun siya. So, due to that, meron din siyang papunta dito. Okay? Due to the AY. So, meron din siyang papunta doon. And meron din siyang papunta dito. Okay? So, naiba pala yung kulay. Okay? So, ito naman, para dito, I will do have the AY. Okay? If this is theta, again, kailangan ko is sine of A. And this is AY cosine of A. Okay? So, mamaya, lagyan natin ng values. Okay? And then, ito, 90 minus theta, pag ano na, no? So, meron daw ako dito, supposedly, on this direction, and then on this direction. Okay? So, this is, ang gagamitin natin, okay, para naman dito is the 90 minus theta or B. So, I will now have is 6,000. Okay? And then, that would be cosine of B. And this is 6,000 sine of B. Okay? So, ito ganun din. Meron akong paganto, and then meron din akong paganto. Okay? So, now, ito, theta naman ang gagamitin ko. Ito naman siya. Ito yung 90 degrees. So, ito, this would become CE cosine of A. And then, this is CE sine of A. And lastly, para dito, so, again, ganun din. Ito yung 90 degrees. So, meron akong pababa. And then, meron din ako dito along this line. So, again, gamit ko is 90 minus beta. So, this would become 3,000 cosine of beta. And then, this is 3,000 sine of beta. Okay? So, ngayon, lagyan na natin ng values. Okay? So, ito, ano ba values nito? AX natin is 10,000 sine of B. 10,000 sine of B. So, that is 8,000. And this is AY. So, 9,000 sine of A. So, you can have it as 5,400. Okay, how about this one? AX 10,000 cosine of B. So, you can have it as, I will be having here, ilan yan? Sorry, AX cosine of B. So, that's equal to 6,000. Tama ba? 6,000, tama. 6,000. And then this one is AY. 9,000 cosine of A. So, you can have it as 7,200. How about this one? 6,000 cosine of B. So, that is 3,600. And then this one, 6,000 sine of B. So, that is 4,800. Okay? CE. Ano ang CE natin? 10,000. 10,000 sine of A. So, you can have it as 6,000. And then this one is CE cosine of A. So, you can have it as 8,000. This one is 3,000 cosine of B. So, you can have it 1,800. And this one is sine of B. So, you can have it as 2,400. Okay? So, ngayon pwede na nating ipag-add. Okay? Ito pwede nating ipag-add eh. So, ang total niya, yung horizontal, so we can have it as 8,000 plus 5,400. So, that is 13,400. Okay? Ito, meron kang pababa na 6,000, meron kang pataas na 7,200. So, ibig sabihin, meron kang resultant doon na 1,200. Ano? Okay? So, lagay na natin dito. Again, points A, points B, points C, and then points C. Okay? So, meron ka daw dito na paganto. Okay, so you can have it as 13,400. And then, meron ka ditong paangat na 7,000. Sorry. Ilan na lang yan? 1,200. Okay, so meron ka na lang itong 1,200. Okay, sa point B, so, ayan, lahat naman, solo-solo na lang eh. Yan. So, meron kang pa ganyan. Puro pa ganyan pala. And then, ito pababa, point B. Ito pataas. And then, ito pababa. Okay? So, lagyan natin ng values. 3,600, 4,800, 6,000, 8,000, 1,800, and 2,400. Okay? Now, with this, meron akong actual loads. Okay, kung makikita mo yung actual loads na 13,000, balik tayo sa topic number 1. Okay, so each segment. Okay, sa segment na to, sa AB, lagyan natin pala ng naming. So we can have it as A, B, C, D. Okay, natatandaan nyo, kinakat natin yung segment AB and then kinukuha natin yung actual doon. Okay, kung compression or tension. Okay? So, try natin i-cut sa AB. Okay? Pag magka-cut ako sa AB, okay, huwag nyo muna intindihin yung mga pataas at bababa. No? Actual loads lang muna tayo. Okay, actual. Actual loads. Okay? So, I will be having here the 13,400. Okay? Nag-cut ako ng section. Okay? So, pag nag-cut ako ng section, di ba, mayroon tayong internal force. Ano yung internal force doon? 13,400. And if it is towards the section, then this is in compression. Okay? So, with that, we could say na yung force ng 13,400 is a compressive force. Okay? So, pwede nyo ulit mag-cut sa B, pwede kayong mag-cut sa C hanggang makuha nyo yung inyong mga forces. Okay? Or, ganito na lang gagawin ko. Okay? So, idodraw ko na lang yung pinaka actual diagram niya dito. Okay? Alam ko kasi na yung 13,400 already, isa lang kinat ko, no, sa AB lang, na compression siya. Okay? So, it means, okay, I will make lahat ng to the right or yung sign nito, direction nito, would be compression. Okay? So, for example, I have here 13,400 na pakanan. So, that is in compressive force, like this one. So, ibababa ko, I will be having here, let's say, negative 13,400 to denote that this is in compression. From A to B, no, constant lang naman yun. Okay, constant lang yun. Okay, I will be having here this one. Kaya lang, pagdating sa B, nagkaroon ka ng 3,400, tapos pakaliwa na siya, ima-minus mo yun dito. So, that is negative 13,400 and then plus 3,600. So, you can only have here negative 9,800. So, aangat ako ng kaunti. No? So, that is negative 9,800. From B to C, wala ulit. Okay? Again, plus ulit to, no? Kasi ang compression natin is 13,400 ito. So, lahat ng pakaliwa, i-add natin. So, negative 9,800 plus 6,000. So, you can have it as negative 9,800 plus 6,000. So, you can have it as no. That is 8,000. Baliktad pala. Ano ang ano natin? Parang baliktad ako. Ayun, 8,000 pala to. This is 8,000. This is the 6,000. Okay, sorry. So, negative 9,800 plus 8,000. So, that is, angat tayo doon. So, ang point na yun ay negative 1,800. And then, pagdating doon, again, meron ka, ayan, magko-close pa rin yung 0, no? So, what does it mean? This is the actual diagram. So, actually, this is the actual diagram. Okay, that is the actual diagram. Okay, so it tells us on the actual diagram that the whole cross-section experiences whole compression. 13,000, 9,000, 1,800. Pero lahat sila compression. Okay, so the body, yung beam natin, doesn't experience any tension. Now, let's draw the shear diagram. Aangat ako doon ng 1,200. Tama? So, I will be having here 1,200. Then, wala akong ibang force A to B. Okay? Then, bababa ako ng 4,800. 1,200 minus 4,800, negative 3,600. So, I will be having here negative 3,600. And then, from there, from B to C, no other loads. Aangat ako ng 6,000. So, negative 3,600 plus 6,000. So, you can have 2,400. So, I will be having here 2,400. No other loads. And then, bababa ako ng 2,400. This is now my shear diagram. Okay? And then, lastly, I will now have the moment diagram, of course. No other moments. Pagdating doon, kukunin natin tong area na to. So, that is, ayun pala, no? So, hindi natin alam yung pinaka-distances nito. Actually, hindi natin lang naman sa tatlo. So, we can have here the total length. Ilan yung total length natin dito? By means, since this is parang 3 and 4, so this is maybe 5 feet. 5 feet, and then this is 5 feet. So, you can have it 5 feet, 5 feet, 5 feet. Okay? So, we will be having here 1,200 times 5. So, you can have it as 6,000 pound-feet. Yun. So, that is positive 6,000. Okay? And then, bababa ako ng 3,600 times 5 minus 3,600 times 5. Saan yun, sir? Para dito sa area na to. Okay? So, equal to negative 12,000. Okay? So, ayun, bumaba. Okay, negative 12,000. Tingnan natin kung magka-close. I-add natin 2,400 times 5 plus 2,400 times 5. So, that is equal to 0. So, negative 12,000 minus 2,400 times 5. Okay. Sorry. This is not... Ano ba to? Negative 12,000. Sorry, I should have it plus 0. Yun. Okay? So, nag-0 siya. Alright. Since this is a prismatic, okay, ang kailangan lang naman is stress. Sabi naman doon, ano, largest stress. So, whether it is tension or compression, I don't care. Okay? So, may dalawang points ulit tayo. So, you can have this one, and then you can have that one. Okay? And at this point, okay, so, ayan, meron ako dong dalawa. Sige, kopya muna kayo before we proceed. So, we just draw the axial, the shear, and then this is the moment diagram. Okay po. So, I will give you 5 minutes first to copy. Okay, so let's continue. So meron tayong dalawang point of maximum moment. So it means at this point B at point C, meron yung tension and then compression. Okay? Kaya lang dito sa point B, although maliit yung 6,000 kumpara sa 12,000, mas malaki naman yung axial niya, 9,800, kumpara dito sa axial na 1,800 lang. Okay, sorry. At this point, this is 13,000 ano. Tapos ito, at this point, that is 13. Okay. Okay, now, we will consider points, 2 points at point B. Okay. Now, para makuha yung maximum, okay, I will just follow the axial loads. Okay, what should I mean with that? Now, ang axial load ko kasi at this point is negative 13,400 in compression. Okay? And then, with this, ang kukunin ko na lang side is the compression side. Okay? Para mag-add. Okay? Kasi kapag kinuha yung tension side, nonsense, no? Kasi magne-negate lang yon. Okay? So, let's see. Sige. Para, for the sake ng matutunan natin, okay, meron tayo ulit top and bottom. Okay? At point B, we have top and then we have the bottom. Okay, again, negative P over A plus MC over I tayo, no? Okay. For the P over A, since this is a compression at point B, so that is negative 13,400 all over A, which is ilan nga yung, ito yung area niya, no? So, 60, 6 times 10. 60, okay? Ngayon, ito, sabi nga dito, nasan daw dyan kung nasaan yung moment mo, if this nasa taas, nandun yung compression side. Okay? So, it means I will be having here minus. Kasi ang top ko is nasa taas. Okay? So, nandoon daw yung aking compression. So, minus M. Kaya lang naka-pound foot pala to. Pound foot. So, convert natin into inch. So, multiply natin by 12, ano? 12 M. Ang C natin is 5. Okay, how about the I? Ilan ba ang I natin? So, ang I natin, again, is P H cube all over 12. So, you have the I. 610 cube all over 12. So, you can have it as 500 inches cube. Inches to the 4, sorry. So, you can have it as 500. Okay? That is the MC over I. So, we can have it as negative 13,000, negative 13,400 all over 60 minus 6,000 times 12 times 5 all over 500. Okay. So, you can have it as negative 943.33 PSI. Okay? Although, alam kong ito na yon, okay? Sa point B, pero try pa rin natin bottom na. Ano yung sinasabi kong nagne-negate? Negative 13,400 all over 60 para sa bottom. Kaya lang, since compression ang sa taas kasi nandun yung moment ko, so yung bottom niya, ang na-experience nun, tension. So, instead na minus, gagawin ko siyang plus. So, again, M, C, all over the I. So, ano yung magiging, nito? Value. So, instead ng negative, minus. So, it experiences 496.67 PSI. Okay? As you can see, bumaba yung value. And instead na compression, naging tension siya. So, at point B, ito yung mas malaki. Stress. Okay? Again, ang tanong is largest stress. Hindi tinatanong is largest compression or largest tension. Pero, kung largest tension ang tinatanong, of course, ito yung lalabas na sagot. Okay? But for now, ang tinatanong is largest stress. So, I don't care about if it is tension or is it is in compression. Next, I will now have this at point C. Okay, ganun pa rin. I will be having here the top and we can have it here as the bottom. Okay, kaya na nasan ba yun? Okay, nasa bottom daw yung compression. So, sure ako kasi compression. So, ito yung value ng 9,800. Compression. So, mag-a-add. Sure ako na nasa bottom yung pinaka-largest ko. Okay, pero let us see pa rin. Okay. Sa top, ang na-experience niya, again, only 9,800. So, that is negative 9,800 divided by the 60. Okay. And then, Yung taas, since ang na-experience at this point ay positive. Okay? Kasi nasa baba yung moment diagram ko, so nasa baba ang compression, so yung taas mo is in tension. Okay? M, again, that is 12 kasi para maging pound inch. C, all over the I. So now, this one would become negative 9,800 all over 60 plus 12,000 times 12 times 5 all over 500. So you can have it 1,276.67 psi. Again, positive, it means it is in tension. How about on the bottom? So that is negative 1,800 all over 60 minus M C all over the I. Okay? So this is now the compressive, and that is negative 1,603.33 psi. Okay? So between the two, the largest stress is 1,600. So at point C, ito yung kukunin ko. At point B, ito yung kukunin ko. Pero sa kanilang dalawa, ano yung pinakamalaki? So largest stress is equals to negative 1,603.33 psi. So this is now the answer. Okay? Pero again, kapag ang tanong, compression, so ang largest na compression ko is negative 1,603.33 psi. And then if tanong is in tension, ang largest ko is 1,276.67 psi. Okay? Depende sa tanong. So, ang tinanong lang naman is largest stress. So, whether it is tension or compression, you have to compare the four. Pero, if ang tanong lang is the largest tension, you have to compare only the tension. And if ang tanong is compression, you just need to compare the compression. Okay po? So, that's it for this problem. I'll give you 5 minutes to copy. Okay, so that would be our lesson for today. So we will be having the pressure vessel, thin-walled vessel, and we will be having also this combined loadings, axial and then the flexural. Okay, so we will deal more on the combined loading soon next week. So for your next session, so we will be having asynchronous, and I will give problems to answer for practice, and you have to put it on your lecture notes ulit. Okay? So I will give that on next meeting. Okay po? So see you next meeting and God bless.